Okay, there we go. I think it should be okay. Is it too loud? What? Oh, it's too. Hello. Okay, is it fine? Uh, okay. All right. So first of all, what I'm gonna do now is so obviously I've done a certain amount of stuff, so it's like sort of a finale, but rather a see if I can just get this out of the way. Okay, so it's gonna be like how to explain this? Like my final time, sort of getting things out the way in a way, I guess. But yeah, let's get started, I guess. Mm. So first of all, let's start from the very top, isn't it? So let me just try getting in here. There we go. So first of all, as you can see, this is just an introduction. So let me just go here. So it's just a certification. So it just tells you about it, how to create an account and the basics, and cloud computing. So obviously this is the client-server relationship model. You know how to deploy stuff, right? So these are the basic stuff. But where things start getting important is when we get to about here. Let me see. Okay, EC2. So EC2 is Elastic Elastic Cloud. I'm pretty sure it stands for, yeah, Elastic Cloud. So apart from that, makes the process of increasing demand capacity, increasing and decreasing capacity easier. As a result, you can access the resources at demand. No upfront investment is needed. You only pay pay what you need. That's facts. Okay. So with that out of the way, instant types. So we have, I think we have application servers, yeah, gaming servers, yeah. So the usual purposes, and to increase, so these are the basic stuff, right? So to increase storage, basically increase the speed of how fast things process, and to have a reliable application where everything is sort of memory optimized, right? So that's basically, and it's easier to access. Bro, did someone just subscribe? The fuck? But anyways, this is the pricing plans. So I don't really need to know about these yet, because there's more important stuff here. As far as scaling goes, so these are auto scaling. So auto scaling is when you don't really have how to explain this. So you just gotta keep scaling it depending on like the dynamic nature of how things increase, right? So that's what auto scaling is essentially, because so there's like a minimum capacity, a desired number, and then we have the maximum capacity, right? So the desired number is like the middle ground, right? So however, the desired capacity defaults to a minimum capacity if not specified. That's facts. Okay, so minimum capacity increases that number of minimum capacity of instances that will be always running. The rest will operate when necessary. So essentially, when you have a minimum capacity of instances, that means that only those instances will be running, and the rest will operate when necessary. You can set the desired number of AWS EC2 instances in the scaling group. Last configuration is the maximum capacity. That's facts. Okay, so capacity of instances to be used. This is facts, isn't it? So okay, so let's move on to elastic cloud load balancing. For example, right here we have directing traffic with elastic load balancing. So what we're gonna do here is a single point of contact for incoming web traffic. Yeah, so it's basically related to load balancing, isn't it? So it's like, you know, balancing things out so that the application doesn't crash, right? So spreading out the load between the resources, exactly. So single point of contact. So a load balancer is a single point of contact for incoming web traffic. The single point of contact means that the traffic hits the load balancer first, spreading out the load between the resources. So that's why the load balancer is important for a application not to crash, right? So let me just say load balancer bouncing, and therefore this is the balancer accepts requests and directs them to the appropriate instances. That's facts. It ensures that one resource won't get overloaded and that the traffic is spread out. EC2 and elastic load balancing are two different services that work well together. So EC2 is obviously the elastic cloud computing and cloud compute, and the load balancing to make sure the instances are not being sort of smashed out. So yeah, that's what load allocation does. It's like it keeps everything balanced out, so the service allocates incoming traffic between the available resources, right? The principle is that this principle is the same with both high and low demand periods. It will allocate between with what is available at any time, right? So incoming what? Incoming what traffic? Web traffic, my bad, sorry. I mean, that's kind of obvious, isn't it? Like, it's all in the web, so I guess I kind of fumbled there, that's fine. So it should be web. Yep, it is web. Just, okay. Messaging. So I'm pretty sure this is something related to applications and microservices. So microservices are obviously like having everything sort of divided, and monolithic is obviously having everything deployed in one, which will be a bigger problem when you have when you got to deal with different things, right? So if your application crashes, for instance, it's gonna screw up the whole thing. With each other, communicate and can transmit the data, fulfill requests, and keep the application running. Components can communicate with each other. Applications are made of multiple components. Yeah, I mean it's made of multiple components. That's the same across both, but this is different. With tight couple components, which exactly components can be databases, servers, interfaces, and much more. Monolithic application can be vulnerable if one of the components fail. In worst case, this can cause the whole service to go down. That's fact. Okay. So microservices, on the other hand, basically have everything sort of divided onto different components. So that way, even if the certain component fails, like everything else will be still running. You know what I mean? Have to keep your service available if one component fails. So I'm just gonna say cloud microservices. And this is kind of basic stuff if you think about it. Monolithic means it's just everything sort of coupled together. Everything's in one application, components, everything sort of coupled to one application. Microservices. So simple queue. So that's what SNS and queue services, the SQS. So notification system. So service is like the one that sends you the can publish messages to many different endpoints. Okay, so notification system which pushes messages to its subscribers. SQS is a queuing system, and the receivers have to pull the messages to be processed and deleted from the queue. So queuing system and the notification system, right? So an SQS and SNS and SQS can work well together. So first of all, let me get a screenshot of this. Let me just put this here, and let me just put it in here, and just say cloud. Fuck. Just say cloud. And let me just copy, paste this here. So the difference between SQS and SNS, so the SQS is a queuing system and SNS is a notification system, and then notification sends a notification to the subscribers, and the QoS is a queuing system, so therefore if you want the messages and the notifications, you got to pull it out, and then pull it out and then delete it from the queue. Messages pull the messages essentially. So apart from that, SQS, so let's dive a little deep into it. I'm missing something here. So for instance, SNS. So publish messages to many different endpoints. That's facts. So JSON, SQS, that's the queuing system, applications, AWS Lambda. So I'm pretty sure Lambda is used for certain use cases. SMS depending on region. That's facts. So let me just do cloud SNS. Cool. So now, oh crap, I think I missed it. Done. There we go. Okay, so queuing system is obviously a queuing system, like just like it says, and it exchanges and stores messages between software components. The service adds the messages in a queue. Users or services pick up the messages from the queue. Once processed, the messages get deleted from the queue. So that's basically what this does. And is a queuing. I can't spell queuing. Queuing. Is that how you spell queuing? Yeah, there we go. There we go. So queuing system. So let me just copy this. Let me just cloud queuing system SQS. So yeah, so simple queuing system service. So simple queuing service. Simple queuing service. So apart from that, yeah, so this is basically responsible for queues. Yeah, so apart from that, what do we have here? So we have serverless compute. So obviously serverless means only the code is deployed. There's no servers running, just like Vercel if you think about it. And yeah, so deploy your code, make the code ready to trigger an event, and then the code will only runs when triggered, pay only when your code is running. So yeah, so this is how Lambda works essentially. So I'm just gonna essentially deploy your code to Lambda, make the code trigger an event. So you deploy and then trigger and then trigger an event, and then the code only runs when triggered. You pay only when the trigger is done. So, and that's when it runs the code, right? So that's fine. Let's just do cloud and how Lambda works. And apart from that, so you can serverless computing helps abstract the infrastructure in the cloud. As a result, it reduces the cost and can help to increase innovation. AWS Lambda can be used to build that. Yeah, exactly. So this is what Lambda does. So let me just get a screenshot of this as well. And cloud, what is AWS Lambda? So it's basically an infrastructure in the cloud. It's abstracting infrastructure in the cloud. So as a result, it reduces the cost and can help to increase innovation. AWS Lambda can be used to then deploy apps and monitor and maintain applications. So you deploy it, you trigger an event, and then once it's triggered, if it's triggered, only when it's triggered, you should pay for it, because that's when the application is actually deployed. You know what I mean? The application is actually running. So containers. So I think we've all known about containers. Containers have everything in one. Have Docker containers, for example. So yeah, it's basically easier to manage everything. So that's why especially microservices really like this architecture, right? The concept of containers. Did I save this? Yeah, I think I saved it. So it's gonna be, let me just copy this real quick. Copy that. Cloud containers in the AWS cloud. So everything's going to be sort of packaged together. So as you can see, we have the applications, the libraries, and the bin files, modules, whatever. And then we have the operating system and the servers, everything all contained to one thing. And then that way it's easier for deploy. Having the application in container makes debugging easier. It makes it a whole application easier because the application is inside of an isolated container. Container remains consistent regardless of deployment. Exactly. So this is important because the container will be given a certain specification. Okay. Yeah, so containers and scale, it is important to design for scale using containers. It can be tens and hundreds of containers, and yeah, exactly. One should prepare for how to manage operations at scale. Exactly. So there's going to be a lot of different containers when it comes to really deploying things and putting things into perspective, right? So we have the what was this again? Container service. Okay, so container service, just like I said, supports. Let me see. Helps you run containerized applications. It is a management system built for scale and high performance. Supports Docker. Okay, so Docker is basically where a lot of people usually containerize shit, right? So Yeah, apart from that, this platform lets you build, test, and deploy applications. So it's obviously Docker. Docker is basically where you containerize shit. They build, test, and deploy applications. So it's obviously Docker and Kubernetes. So I have no idea what Kubernetes properly is, but it's also called EWS, EKS. EKS is a managed service that lets you run Kubernetes on AWS. It is built for scaling with Kubernetes. Kubernetes is an open source. Okay, helps you deploy and manage containerized applications. Kubernetes has a large community. AWS continuously keeps the AWS EKS service running, updated to the latest Kubernetes features. EKS is used to run and scale Kubernetes applications in the cloud and on premises. Deploy applications in different ways. Cloud deployment on your infrastructure, and deployment with your tools. Now, as far as this goes, the service, it's also called EW. Okay, managed service that lets you run Kubernetes on AWS. Is built for scaling with Kubernetes and deploy and manage containerized applications. Has a large community. Keeps the EKS service updated to the latest Kubernetes features. So yeah, I mean, as far as let me just copy this real quick. So obviously we have let me see. To deploy and manage containerized applications, right? That's facts. And so Kubernetes is a larger community. What's the difference between these two? Okay. Okay. Hmm. Right. Okay. Got that. So it's basically like the container orchestration. So Kubernetes is like the older brother of Docker. Docker is basically used to containerize, and then Kubernetes is used to manage a bunch of different containers. So why Kubernetes is used with Docker? Docker is used to containerize, while Kubernetes is used to I can't spell orchestrate many different containers. Okay, I can't spell this shit. Fucking spell orchestrate. Fargate. What is this? Oh my god, there's a lot. Serverless compute for containers. So obviously serverless means that everything's sort of deployed on the cloud, and therefore you don't quite have to do anything, right? I mean, you don't have to manage servers and stuff. So it helps deploy and manage applications. Fargate manages the infrastructure for you. Okay, you do not have to think about provision of servers and infrastructure management when using Fargate. Okay, well, how is that any significant from the other stuff? The serverless service, Fargate has a pay-as-you-go pricing model. It lets you focus on doing the most important things, building your awesome applications. Okay, the glazing is crazy, but I guess we'll take that. So what I'm gonna do right now is I'm just going to say serverless so I guess is Fargate, so I have a question. So is Fargate AWS's way of using serverless computing? Okay. Okay, so it's Fargate. So Fargate is used to, it's basically AWS's way of having things serverless. So it's obviously, you deploy the code and then everything works from there. You don't need to worry about servers and stuff. It's the same thing as Vercel. How is it any different from Vercel? It's the same thing as Vercel. So, yeah, exactly. So, yeah, okay. Okay, so just can we just summarize it? Okay. Oh, right. Right. Okay. Right. Hmm. What the heck? Oh my. Okay. Oh my God. I think I'm out of storage right now. Give me a sec, guys. Holy shit. Yeah, I am out of storage. That's crazy. Wait. Let me just delete. I have so much shit on my computer. That's crazy. Wow. Let me just delete a few of these videos. Because there's so much shit on my computer right now. I'm not too sure. But yeah, so as far as scalable container services for backend apps, scalable serverless functions for frontend apps, and this is Elastic Cloud Cloud Computing Service and Kubernetes compared together. So exactly. So right, okay. As long as I have the difference between Fargate and Warsaw, like I'm Gucci, you know? The difference between Fargate and Warsaw. Okay. So as far as okay. Ah man. Okay, so has global infrastructure with data centers all over the world, labs and across the globe or to a specific location. I mean that's facts. Uh, build and deploy where you want. That's facts too. Selecting a data center near your users will reduce the latency and make yeah, that's facts. I mean that's kind of common sense. Uh, hmm. Right. Okay. Hmm. Okay, so it seems like data regulations, customer proximity, service availability, and pricing, obviously. Hmm. Yep. Hmm. Right. Okay. Right. So keep the infrastructure near you, and then the service, the actual service, nearby them, pretty much. And the yeah. Right. Okay. So you gotta have the infrastructure running near you, and then the applications running in a data center near the customer. So obviously, that way they get no problem with the latency and the government regulations and stuff. There are many factors in how the prices are set. Example, the price may vary. Okay. Mm. Okay. Hmm. One sec. The fuck? Oh crap. I was supposed to be trading today. Oh shit. Uh, it's fine. I'll just focus on this for today. Hmm. Availability. Right. Right. Man. Right. Hmm. Yeah. This is obvious though. This is like usual FNBR stuff. If you know what I'm saying. Usual FNBR stuff. We have a few servers. Obviously we have California. We have the where is this from? Oregon? Not too sure. Then this is, yeah, so it's going back and forth. That's the point. Going back and forth. Mm, mm, mm. Multiple. Multiple, isn't it? What? Group? Okay. Cool. Okay. Hmm. So it's the fastest, it's the closest location pretty much. The edge location. Get it? Because it has an edge. Okay, that wasn't funny. What am I on? I'm actually. What? Hmm. Hmm. Copies and stores lots of data. Uh, so software deliver content faster and cheaper, obviously. So they're stored in hardware that can deliver content fast. For example, yep. Main job of cache is to deliver content fast. Hmm. 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 Oh, management console, CLI, and SDK. Yep, exactly. So you pretty much use it in like different languages. You can like get it directly linked up. So it's a using cloud. So obviously we have the management console, the CLI, and finally we have the SDK. Boom, easy. Hmm. With one tool, allows you to automate actions on services with scripts. Exactly. Management console is obviously the management console. That's pretty easy. Access and manage AWS services. So this is common stuff. SDKs are usual libraries that are pre-built. Hmm. Yeah. I'll just do it just for fun. What? Okay. Okay. Wow. That's crazy. One letter. Okay. Provision services. What does provision mean? Okay. Stop. Hmm. Hmm. Right. Hmm. Ah, man. Okay. Well, you can treat your infrastructure as code. Okay. Elastic Beanstalk, and what's the other one? Okay, forgot. Uh, Cloud Formation. I gotta read through this once again. It's obviously these two, but you can treat your infrastructure as code using these services. You can build an environment by writing lines of code. So using the AWS Management Console to provision resources individually. So okay, so everything should be sort of the infrastructure is as code. Okay. Got the environment by writing lines of code. Okay. Fire. Yep. Seems pretty good. On to the next one. So obviously this is the easiest. DynamoDB is basically dynamic, and relational database service is obviously RDS. So everything's all relational, just like it says. S3 is like the simple storage service, and EC2 is the usual. But web infrastructure, Elastic Beanstalk is a web infrastructure management service. So Beanstalk handles deployment and scaling for applications and services. So Beanstalk helps automatically manage AWS services and set up configuration, scaling, and provision. Okay. Elastic Beanstalk supports many platforms such as. Okay. Ah, man. So it's obviously cloud orchestration service. So why would I be using this when I can just use? Hmm. Right. Yep. That's right. Elastic Beanstalk. What kind of name is that? Web infrastructure management service. Infrastructure. Hmm. Hmm. Jesus, man, it's been 40 minutes and this is all I've done? That's crazy. Handles the config and provisioning of the resources described in the template. Makes it easier because you don't have to configure the resources individually. Okay. What's the answer for this? Hmm. Why am I tripping? Swear I'm tripping. Something's up with me, bro. Swear. Can't focus, like, something's really fucked up. Hmm. It's obviously this. Okay. Let's go. Yay. Wow. I'm so excited. Let's go. VPC is just obvious. Internet gateway. Client sends a request through the internet and the VPC. Into the VPC, so this is obviously the VPC. So these are the so the subnet is basically within the VPC. Is that what I'm saying? Interesting. So we just call it Cloud Internet Gateway. And virtual private gateway. So it's not a VPC at that point. Cool. Direct connect. You just copy this. Man. It's obvious. Exactly. Come on. Why is it so slow? Okay, so subnets and network access control this. So it's obviously just letting as far as like it's subnets are like services within services, right? Sub services, I guess. Subnet is a section of a VPC, okay? Subnet allows you to group resources, yep. Yeah. What? Okay. 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 Okay, is it fine? I think it's fine. There we go. Pretty much, yeah, what's up, Zed? What's up, what's good, thanks. I have no idea how to spell your name, to be honest. I don't think remember me. I don't. I actually don't. I was so OG. Really? I was so OG? Okay. The subnet allows you to group resources. Groupings can have different, sure. The groupings can have different security or operations needed. Operation needs. You can have subnet. My chat's pretty delayed right now because you know, I don't know, some huge delay here, so I might respond like when I'm seeing it. It's like pretty delayed, you know. You can have both public and private subnets, and yeah, so this is a virtual private cloud. Subnet allows you to group resources. Groupings can have different security or operations needs, and you can have both public and private subnets. Subnets have resources that can be, yep, such as w3schools.com. Private subnets have resources that can only be accessed through the private network. For example, yeah, exactly. So it's like a network within. It's a subnetwork pretty much. I'm just gonna double confirm that theory, to be honest. For example, cloud subnets. Yeah, subnets. Subnet is a virtual private cloud. The subnet allows you to group resources. Groupings can have different security or operation needs. You can have both public and private subnets. So essentially, subnets and subnetworks, isn't it? Subnetworks, isn't it? Yeah. Yeah. Exactly. Easy stuff. In a virtual private cloud, I can't spell that properly. Requested data sent as a packet. A packet is a package of data sent over the over a network or the internet. Enters the VPC through an internet gateway. Before entering a subnet, it checks for permissions and checking permissions such as who sent the packet, who will the packet communicate with the resources in the subnet. Right. Packet is a package of data sent over the exactly. Enters the VPC through an internet gateway. Entering the subnet, checks for permissions and checking for permissions such as who sent the packet, how will the packet communicate with the resources in the subnet. That's facts. Quick access control list. Hmm. Yep, that's facts. DNS is what they use to access your website from the browser. It's like a phone book. It connects the IP address to the domain name. That's facts. That's facts. Yep. 53 is a DNS web service. It routes and end users to internet apps hosted in. Okay. Route 53 connects users and their requests to AWS resources and external resources. Route 53 has a feature to manage DNS records. You can register new and transfer domains with Route 53. You can manage all your domain names from Route 53. It's a web service. It routes users to the okay. Yep, that's right. Cloud. Fuck. Use Route 53 at AWS CloudFront. This is Route 53 in CloudFront. The load balancer, which is pretty much in the middle. The fuck. Cool. Three EC2 instances in an auto scaling group. The group is attached to an application load balancer. User requests data from the website. Route 53 uses DNS resolution to identify IP addresses. Yep. Then the data is sent back to the user. The user request is sent to the nearest edge location through CloudFront. The CloudFront connects to the application load balancer. The load balancer sends the packet to the EC2 instance. Interesting. Interesting stuff. Interesting stuff. Okay, so let me just copy this and just paste it over here. Fuck. Okay, that's fine. DNS connects the IP address to the host name, isn't it? What? What's up with this? Okay, something's wrong with it. So, third recap. Hmm. Hmm. Cool. I'm confused. What? How did I end up here? Third recap. So where was third recap? Oh, it's because I'm okay. Storage and DB. Basic storage concepts. Okay. I just had to. I'm sorry. Man. Access a physical hard drive. Provides temporary storage for EC2 instance. Hmm. Man. That storage is a storage volume that acts as a physical hard drive. It provides temporary storage for EC2 instance. The data is an instant in store versus during the lifetime of it of my god, I can't speak. The data is in an instant store persists during the lifetime of its instance. Instant store is a storage volume that acts as a physical hard drive. Provides the temporary storage for EC2 instance. Facts. Okay. The data in an instant store persists during the lifetime of its instance. If an instance reboots, the data persists. Okay. When the instance hibernates or terminates, it will lose data in the instant store. So it's like if an instant store starts from a stop state, it might start on another host where the instance does not exist. It is recommended to avoid storing valuable data in the store instance. Instance stores are good for temporary files and data can be easily recreated. Data that can be easily recreated, that's fair. So I'm just gonna copy this as well. Let me just put this here. Let's say for example, if I just copy what are instance stores, boom, just like that. EC2 instance is an attached instance store. EC2 instance is stopped or terminated. Elastic storage for you, is it? Temporary storage, isn't it? Temporary storage. Exactly. That's just like to store for an instance, pretty much. Elastic block store. Elastic block store is also called Elastic Block Store. EBS is a service that provides provides storage volumes. You can use provided storage volumes in an Amazon EC2 instances. EBS volumes are used for backup for data that needs to persist. What the fuck? Hmm. Yep. Cloud. Interesting. Elastic block store is a service that provides storage volumes. You can also use provided storage volumes in EC2 instances. EBS volumes are used for data that needs to persist. It's important to back up the data with EBS snapshots. Okay, so you use instances and then you use block storage to sort of save the data, right? So you use instant storage to just temporarily store stuff, and you use EBS to back up stuff because it's a block store. And yeah, that's pretty much as far as I can see. So EBS snapshots, when EBS snapshots is an encrypted data backup. The first backup of a volume backs up all the data. Every next backup copies only a block of data that has changed since the last snapshot. Saves on storage costs not duplicating data. Okay, so it doesn't duplicate data, it just pretty much updates itself, like appends itself pretty much. So pretty cool. Provides what volumes? Storage volumes. Okay, I'm an idiot, I swear. Storage volumes. Hmm. Terabytes, that's facts. Hmm. Okay. Word classes. Fire. Uploading any type of file. S3 allows to upload any type of file. There we go. There we go. Elastic Beanstalk versus S3. So data is stored as blocks. Store block can size up to 16 KB each. Okay, that's a huge amount of data. Faster performance than S3. Data can be modified. Individual object size can be up to 5,000 gigabytes. Data does not suffer loss, degradation, corruption for a very long time. Data can be modified unless re-uploaded. Right. Okay. So everything's stored as objects, and this is stored as blocks. So these objects are made of data and metadata and keys. So that's facts. Is objects. No, this stores as blocks, my bad. So says objects. Blocks. My bad. Blocks. Those that's objects. And you get a screenshot of this. Yep, there we go. Copy this real quick. Elastic Beanstalk stores as data blocks, and S3 stores as objects. There's a key, metadata, and data, metadata, and keys. Unique identifier. So it's basically the key value pairs, I guess. Fire. Disrupt application. Elastic file system. Elastic file system. Let's just call it elastic file system. EFS. It's obvious. RDS, relational database systems. Service. My bad. Enables running relational databases. So these are the relational databases for relational databases you gotta use RDS databases. Gotta use RDS, and for non-relational you can use DynamoDB and stuff like Mongo. So you can use DynamoDB. Exactly. So it's all keys, IDs and stuff. So it's relational. Oh, that's fucking obvious, isn't it? Also, it's a database in itself. It's a serverless database. You do not have to manage servers or operational systems to use it. That's facts. Supports these engines. Right. Okay. So obviously you gotta use these relational databases. It helps you like use these like consoles within this itself. But then like when it comes to mm, so it's obviously non it's an unrelational NoSQL database. It's a serverless database. DynamoDB is a high performance service. It's a serverless database. You do not have to manage servers or operational systems to use it. That's facts. Non-relational database, one of these structures. Right. Key value pairs. Ooh, ooh, ooh. Photography. Remove any attribute from any time, any item at any time. Example of a non-relational database data. Non-relational NoSQL database. That's fucking obvious. Right. This is obviously more complex. Relational databases are obviously more complex, but so that's why it's like much more what's the word for it? Slower when you're fetching a lot of different data. It's like the whole overall complexity is higher. And relational tables. No. Source data in database tables. Okay. Documents. This is obvious. Big data analytics. Okay. It's a big data analytics service. It can help. It can gather information from many sources. Assist you with getting connections across your data. Powered by SQL, AWS design hardware, and machine learning. Right. Empowering. It's in Redshift. Big data analytics. Analytics. Okay. I'm assuming. Yep. There we go. Database management system. Is that what? Okay. Migration service. My bad. Migration service helps you move data between databases. This is a source database and a target database. Source database and a target database. Yep. So yeah, exactly. From where it's migrated to. Cool. Source to target. So let's say cloud DBTMS source to target. Source DB to target DB. Yep. Yep. cloud. Going to use this. There we go. Combine multiple databases into a single one. Say for example, single. Yep. Different database types. It offers more types of databases. Should you need to use them. DocumentDB is a document based. It is a NoSQL based database. Suppose MongoDB. It is okay. User profiling, cataloging. Okay, so this is each of the document. I mean, this is like MongoDB. Supports MongoDB. AWS Neptune. Cool. I'm just gonna leave this for a little later. So let's go on to the next slide. For example, this one is Cloud for recap. Right. Let me just double check on this. Yep. Oh, okay, yeah. Okay. S3. Yep. Any type of file is allowed. Okay, so let's move on to the next one, which is cloud security. So obviously we have MFA, AES, which is application something service, TLS, SSL, transport layer security, secure sockets layer, AES, which is application encryption security, advanced encryption standard. Okay. So this is the identity access management, multi-factor authentication. Right. Look, what did I just do? Let me just copy this. Cloud. Security introduction. No, I'm just gonna say something like, security policies. So it's obviously cloud security policies. And let's go on to the next one. So it seems like shared responsibility model. Shared responsibility model is a concept of dividing responsibilities between AWS and a customer. Customer is you. Fuck, what did I just do? Customer is you. AWS's responsibilities are the security of the cloud. Customer responsibilities are security in the cloud. AWS is security of the cloud. Yeah, in the cloud. Yep. So shared responsibility, yes. Yep. Cloud. Shared responsibility model. It's obviously like they build the infrastructure, secure infrastructure, and you are responsible for being secure in the infrastructure. That's what they're saying. Responsibility of a customer. Yeah, exactly. Yep. Okay, so it's a good thing. Shared responsibility is about security. Is about security being a customer responsibility. Customer. Cloud responsibility? I don't know. What is it? Shared responsibility facts. My bad. Okay. Let me just say cloud shared responsibility is about shared responsibility. There we go. Cool. User access. Now when it comes to user access, we have root users, policies, groups, roles, multi-factor authentication. So yeah, so as far as permissions and stuff goes, right? So it's all under IAM and so obviously this is the owner, right? Has full access. Right. So do not create right, that's facts. So the root user, obviously we know what this is. So use it to use the root user to create new users pretty much, and then like use those other users. Use it only when like it's like completely necessary. So you give access to certain users and user persons and entity person of application that interacts or with AWS resources and services. User is made of credentials and a name. Is created without permission by default, as facts. And the root user can grant permissions to the IAM user. Yep. With identity access management users. And it has recommended that you create one IAM user for each individual. So, yeah. Users. Yep. IAM policies or denial allow permissions. Mm-hmm. Hmm. Yep, that's facts. Better way of staying secure. Collection of IAM users is called a group. IAM policy assigned to IAM group grants permission to all the users of that group. Okay, so it's like a common shared policy. So it's like if you fuck up there, that's a big problem. All users of that IAM group. Temporary access to services or resources. When IAM role is given, IAM user, service, or application must have switch permissions to switch roles. It's best. Is it temporary access 1 to services or resources? Before an IAM role can be given, IAM user, service, or application must have permission to switch roles. It's best for use cases where temporary access needs to be given. What does that mean? Okay, so role is temporary access to services or resources. Right, before an IAM role can be given, must have permission to switch roles. Right, so they must be given permission to switch roles. Okay. So let me just, so they need to be given permission to even switch roles in the first place. Permission to switch roles before an IAM role can be given. So services or resources, yep. And temporary access needs to be given. Yep. Multi-factor authentication, so obviously is a multi-step authentication can, yep, this is obvious. Entity, an entity. Okay, fire. Organizations. Now, when it comes to organizations, there's one more thing. So, is a container of your AWS account comes with an organization root user by default. It allows you to manage permissions of your organization's accounts. So, as far as permissions in AWS organizations are controlled by service control policies, CPs allow you to restrict AWS resources and services for each account. Groups of accounts in which in the AWS organization or use are used to manage accounts. So with the same or similar permissions more easily. Permission policy of OU is applied to all OU accounts. AWS organization allow you to manage set your accounts. What is it then? Permissions, okay. Permissions, I mean that's kind of obvious. But I got it wrong, so let me copy this. Cloud permissions. Container for your AWS account. Permissions. Yep. Okay, so it's been 1 hour 23 minutes. I gotta hurry this up. Cloud compliance video. Artifact. The service provides access to compliance reports. AWS security on demand. Agreements and reports. Agreement and reports. If I submit this, let's go to the next one. Denial distribution of service. Let's submit this answer. Can I submit? Okay. I mean, that's kind of obvious. But DDoS attacks are like denial of service attacks. So distributed denial of service attacks. That's DDoS. And from different sources. DDoS attempts to make an application or website inaccessible. The attacker can come from more than one attacker or single attacker that uses bots. Bots infect the computers that automatically flood the application with, or exactly. So this is the distribution. Like it's coming from more than just one. From a single source. This is coming from a infected computers. Yep. Cloud DOS versus DDoS attacks. Yep. Key management service ensures that the security of your application data with cryptographic keys is a sequence of characters that mean exactly encryption and then decryption. Yeah, you are in complete control of your keys. Right. Cool. Threat detection service. Web application firewall. It monitors your application's network requests. It can also lava block network traffic. Web application firewalls uses ACL. ACL is what? Web access control list. Okay. Access control list. Okay, that makes sense. So let's say, for example, cloud. Yeah, it's a AWS web application firewall and Amazon inspector. That's helps you improve application security. It also helps you improve applications compliance, check application for software versions and other vulnerabilities, offers you a report of all security issues, solutions, recommendations for your application. So it's an overall application checks for software versions and vulnerabilities, all of your security issues and solution recommendations for your application. That's really good. Cloud Amazon inspector, so it inspects everything and reports back, right? Just like an inspector. Guard Duty is a threat detection service. It detects threats for AWS resources and infrastructure. It does so by constantly monitoring activity on the network. Like Amazon inspector, it reports found threats and fixes recommendations. Cloud, let's say Amazon Guard Duty is a, okay. Cool, interesting. Firewall. No. Threat. What activity? Network. Okay, network. Yeah, I mean, firewalls essentially monitor network activity, right? What if I just go back for a second? Okay, so obviously key management service ensures the security of your application data with cryptographic keys. So obviously a KMS is a key management service, and they use cryptographic keys by encrypting and then decrypting if you need it. So now you're in complete control of these keys, and then you can use certain users to manage these keys with certain permissions, right? So for example, if I just copy this and if I just paste it here, and if I just say AWS KMS, and if I give it some space, the web application firewall and the inspector. So the inspector reports back. Web application firewall is used to sort of control the traffic, network traffic, and web access control lists uses web access control lists. I can't speak. Guard duty is obviously it checks for like the it constantly monitors the activity on the network, and it detects for threats in for AWS resources and infrastructure. And again, it was an inspector. It reports found threats and fixes recommendations. Network activity has been monitored by guard duty. Okay, so next we have so this is just a recap. So we have the security, a shared responsibility model. That's the client and the customer and the Amazon itself. What else do we have? User permissions and access, different users, root user, and then creating sub-users under it, groups, and shared permissions under groups. Organizations, which are pretty much, again, just like I said, organizations are pretty much groups, right? To manage accounts. Okay, so organizations allow you to manage all manage permissions from one organization unit. So organization units are groups of accounts in the AWS organization. Okay, so pretty much you can manage the permissions of these accounts as a whole, right? With same or similar permissions more easily. The permission policy of OU is applied to all OU accounts. That's facts. So organizational units, as far as organizational units go, it helps you sort of manage everything from one. So permissions for each of these accounts. That's what I'm saying here. Okay, so apart from that, we have compliance. So compliance, as far as artifact services, agreements and the reports. So agreements are like you know, the individual manager individual agreements and stuff in between. So cloud organizational units. Yeah, so that's pretty much I forgot to place the. Okay, let me just get rid of this for now. Organizational units. So pretty much you can just you can manage all your AWS accounts from accounts and their permissions from one place. That's what it is. So let me just copy this and let me just paste it over here. Yes. Yeah. Okay. So as far as denial of service attacks, obviously you know what denial of service attacks are. You're just sending a bunch of bots, but if it's from one computer, it's gonna be, you know, if it's a single person attacking, then it's a denial of service. Distributed, which means more people are coming into the picture. Security, additional security services. So we have KMS, which is a key management service. So you encrypt, you decrypt, you keep under certain users, which have certain permissions. That way the keys don't get lost, right? You can keep them, you know, complete control over it. Web application firewalls, you know, control the network traffic, and the application access control list is used to, you know, it uses the access control list to sort of monitor and allow and block traffic, right? So apart from that, inspector. So inspector looks for vulnerabilities and stuff within applications and security issues and solutions. Exactly. So it gives you the checks for vulnerabilities, and then it suggests what needs to be done instead. So for all these security problems, including software versions and other vulnerabilities. So guard duty is one of those other things that sort of reports and fixes recommendations as well. So it reports, fixes guard duty. Guard duty like Amazon Inspector. It reports found threats and fixes recommendations, just like everything else. Apart from that, I think we're done here. Let's go to the next one. It's been 1 hour 35 minutes. Crazy. I gotta go through this at the end as well. Let me just close this for now. Monitoring and analytics. So now we have CloudWatch, CloudTrail, Trusted Advisor. So okay, so we're going on to these stuff now. So let's go into CloudWatch. So CloudWatch is a cloud monitoring and management service. Let's monitor your resources, and it is a web-based service. Configure the service to monitor and set alarms based on your metrics. So you set alarms and stuff. configure the service to monitor and set alarms based on your metrics. Okay, so let's say, for example, let's say Amazon CloudWatch. Let me just paste this here. Okay, so CloudWatch alarms. So you certainly you set certain alarms with you know certain thresholds, right? So used to control resources. For example, stop idle on near inactivate. Yeah, right. So you can just shut them down and save money pretty much. So that's pretty good. CloudWatch dashboard can give you an overview of your resources in a single view. CloudWatch gives insights across AWS services. You can make many dashboards based on your needs. So as you can see, we have this right here, and it seems like so if it's inactive, then there's no point having it running, right? Gives you an overview, right? Right, okay. Monitor resources. What is it? Control? Okay, cool. Okay. CloudTrail. Go on to the next one. Okay, so CloudTrail actions on your account as a trail. Example of data logs, time, IP address, and much more. Facts. CloudTrail gives a complete history of user activity and API calls on your resource. That's facts. Events, okay. Okay, I gotta get back to this. So it's pretty much like can be used to create events. Events can be set up to understand what, when. Okay. CloudTrail, interesting. So you can like sort of see what's happening. It's like trails, like logs, pretty much. So if you just do this, copy, cloud, Amazon, CloudTrails, used to monitor what's happening on the cloud, obviously. Plus, when it comes to, you can create events to monitor certain scenarios and insights. Lets you detect unusual API activities on your account by automation. Okay. Cloud Trail Insights helps you understand what's going on, and yeah, cool. Okay. Logs actions on your account as a event. No. Logs. As a trail. As a trail. Yep, that should be the answer. Trusted advisor. Let's see. It is, yeah. So we just close these. It's a trusted advisor. I think okay. It's the basic. It's trusted advisor. Cost. Okay. Security. Follow up service limits. Returns a list of recommended actions. Okay. It will also provide recommendations for learning material to understand AWS practices, best practices better. So cost optimization, performance, security, fault tolerance, and service limits. Trusted advisor. So this is a dashboard. Access trusted advisor from the console. That's okay. So let me just say cloud trusted advisor and the fuck. Trusted advisor works based is a web-based real-time recommendation service. Service checks your account and compares its findings to following categories: cost optimization, performance, security, fault tolerance, service limits. Turns a list of recommendation actions. Okay, that's interesting. So let me just take a snapshot of this. And Trusted Advisor has a dashboard. Dashboard is web-based. Access Trusted Advisor from the AWS Management Console. That's pretty cool. The dashboard gives you an overview of the completed checks and results per category. Green checks, no problems. Orange triangles on recommended investigations, and red circles recommended actions. So cost optimization, what is it? Performance, okay. Performance, security, and fault tolerance. Performance. Okay. So it seems like I got this right here. So that's okay. Cost optimization, performance, security, fault tolerance, and service limits. Green checks, no problems. I mean, this is the usual stuff, isn't it? Recommended investigations and the recommended actions. Let's move on to the next one, which is pretty much monitoring CloudWatch, the usual stuff. Okay, so let's go on to the next one. Pricing and support. Pricing support models, free tier, billing, budget, cost explorer, pricing calculator, and marketplace. Okay. This is what I was always using. Always free, 10 months free trials. Okay. This is obvious, isn't it? Right. Right. I mean, this is obvious. Trials. This is obvious. So, but I'm just gonna do it just because it's fun. Pricing models. Different pay as you pricing options. Pay only for the resources that you need to use. No need for licensing agreements. Pay less when you reserve. Requires a commitment for future consumption. You used to pay no matter if you use the services or not. Reserve resources will give you a discount. Okay. Alright, I gotta take a piss in a bit. I gotta take a piss, hold on. Hello? Oh wait, fuck. What? Hello? Okay. Alright. Yep, there we have it. Let's see if I can do it. Probably, maybe, I don't know. Pay less, pay for what you use, pay less when you reserve, pay with volume-based discount when you use more. Service gets cheaper the more you use it. Pricing per unit gets lower when you cross the threshold. More use, pay less. Pricing calculator, calculator lets you create a cost estimate for the, okay. This is obvious though. This is nothing complex, but as far as pay when you reserve, so it's like when you know how much it's gonna cost in the future, and then volume based on best to base discount when you use more. So per unit gets lower when you cross the threshold or use pay less. Pricing calculator. Yep. Yep. See the billing dashboard. Compare billing periods. We were spending, for example, daily, monthly, or year to date. Find out how much you're spending, how much you have on left on the free tier, saving plans, create cost and usage reports, and this is usual stuff. Monitor. Compare. Right. Okay. Hmm. Consolidated billing. Hmm. Mm. Mm. Okay. Mm. Cloud Adoption Framework. Try Cloud Adoption Framework, and it walks you through the migration process, migration of applications to the cloud. Is a framework that walks you through the migration of the application to the cloud, and provides suggestions in assisting you in the migration process. Perspectives. Yeah, I mean, migration. So applications to the cloud migration. It walks you through that. Cloud migration services, migration strategies. Yep. Replatforming, rehosting, replatforming, refactoring, repurchasing, retaining, retiring. Retiring. It is this. Yep. Replatforming, refactoring, repurchasing, retaining, and retiring. Yep. Snow family. Hmm. Yep. Hmm. So you deploy it on Lambda essentially. So you deploy the application on Lambda. Yeah. In this eighth section, you have been introduced to the following concept. Web services to deliver digital training content to our students. Damn. Okay. Migration strategies. No snow family. Innovation with. Okay. Slow journey. We'll just skip through this for now. The architecture framework. So it's a tool that uses best practices to find improvements for applications in the cloud. Helps you in 5 areas. Those areas are called the 5 pillars of AWS Visual Architecture framework. So operational excellence pillar. Systems improves supporting systems and processes and procedures. Includes okay. Security. So well architected framework. Yep. Awesome. So what's next? 9th recap. The architecture framework and benefits of AWS cloud. Exam preparation. Hell no. Okay. I gotta study this in detail. So subnets is obviously subnetworks. Public subnets can be publicly accessed. Private subnets can be privately accessed. And yeah, you just call it cloud private subnets. Have resources that can only be accessed through the private network. Yep, exactly. So network traffic in a virtual private cloud. Requested data is sent as packets, and you sort of double verify this using the firewalls. Packets of data sent over it, yeah. Then they would enter the virtual private cloud through an internet gateway, and before entering a subnet, it checks for permissions, checking permissions such as who sent the packet, how will the packet communicate with the resources in the subnet, and depending on that, we have access control lists when it comes to really approving data into a virtual private cloud, right? Stateless packet filtering. So the ACLs do stateless packet filtering. They have no memory and will forget the request once checked. Their job is to check the packets that go in and out, and it uses your set of rules to approve or deny access. So security groups is a firewall that controls inbound and outbound traffic. The feature is specific for an EC2 instance. Packet filtering is obviously it filters out packets in the past, where the actions that they have done with the packets in the past. Configuration, ACLs and security groups can be configured. Configuration means adding custom rules for the traffic. Is a subnetwork. Is a subset. I don't know. Subset. Subsection. A section of VPCs. So I'm just gonna take this and I'm gonna say cloud read again, because it's basically talking about the traffic. So everything's sent as packets, and packets basically packages of data that are sent over the internet. And then once these packets are sent, the virtual private cloud will sort of verify if this is enters through an internet gateway. Before entering a subnet, it checks for permissions, who sent the packet, how will the packet communicate with the resources in the subnet, and control lists, so access control lists. So these are used to, in the firewall itself, it's used to allow or block certain resources or certain people from entering the private access cloud, virtual private cloud, pretty much. So as you can see, if they don't meet the requirements, it controls the traffic at the subnet level, and if they don't meet the requirements to enter the virtual private cloud, then obviously people they're going to be sort of denied, right? So stateless packet filtering. So as you can see, this is again stateless stateful packet filtering. So we'd like to enter a check with you on the list. So you to enter and to exit, you need to check. So they have no memory, and you need to check. But in this case, it does keep a stateful, means it keeps a state of who entered and who left instead. So let's say, for example, in this case, stateless means it doesn't keep track, right? No memory once the request is checked. Exactly. So that's stateless, and for stateful, it's the opposite, isn't it? So stateful is pretty much keeping track of the state and the users that entered. So that's pretty much stateful. So it obviously knows when you enter and when you exit, right? So configuration is ACLs and security groups that can be configured. Configuration means adding custom rules to the traffic. So as far as cloud configuration is ACLs and security groups that can be configured. Configuration means adding custom rules for the traffic. So ACLs, what does an ACL stand for? Nation networking. Access control list. Okay, my bad. I just remembered that. What? ACLs, access control lists, and security groups can be configured. Configuration means adding custom rules for the traffic, and yeah, this is the custom configuration rules in the middle, I'm assuming. So it checks through this network access control list, and then it redirects to the public subnet. So sort of verifying if certain people that are entering the virtual private cloud is verified or not, just to avoid DDoS attacks, right? So apart from that, is a section of VPC. It's obvious. This is redirected to some random thing. Availability zone is a single data center or a group of data centers, correct? Cloud exercises. I will do this tomorrow. In fact, I gotta go through the notes again as well. Cloud quiz. So I'm assuming this is something similar. I think I might have to pay for these stuff more. ML. Okay, so these are the usual ML stuff. So I think I can just I think I'll be fine as long as I learn the basics of engineering. I don't think I need to go as far as ML. Serverless, obviously we know what serverless is, but it seems like it's more within serverless. So I think I'll do that tomorrow. So serverless, obviously we know that it's for people who just want to deploy it and just get out. Think serverless, synchronous. Right. Yeah, I'll go through this tomorrow. I didn't realize there was stuff within this as well. So yeah, this is diving deep into serverless architecture. So I'll go into this tomorrow.